All right. Good evening, everyone. Hope you guys are having a nice Wednesday out there. We've got Hilda saying good evening, Sue says hello, and Emma says hi as well. Thank you guys for tuning in tonight. And tonight we're going to be talking about cold fronts, warm fronts, stationary fronts, all the fronts. I even got a cool demonstration coming up at the end of the at the end of the slides here, so make sure you stay tuned for that. But we're going to be talking about what the heck are the fronts and how do they impact us here in West Texas. And anybody who lives here long enough knows that we have all kinds of different boundaries coming through. We have cold fronts that can really knock down those temperatures. We got dry lines and all that kind of good stuff. So we're going to touch on some of those here tonight. So it should be something kind of interesting. Just wanted to say thanks to everyone who tuned in last night for Jeopardy. That was a lot of fun, and it seemed like you guys all enjoyed trying to chime in with the correct answer. So who knows? Maybe you want to take some notes on some fronts here, because that could be on the next edition of StormTracker 9 Jeopardy. Who knows? So we shall see. We'll try and maybe do that again next week or the week after. That's a pretty good time. I'm going to grab the feed real quick. Make sure I'm seeing all your comments. Abigail tuning in. Stephanie. Be careful, Stephanie. Thanks for watching, Stephanie. All right, let's talk about all these kinds of fronts. And again, I got a demonstration here coming up at the end, so stay tuned for that. That's why I'm not going to be on camera for this, because I do have it set up over in our, I don't know what you call it, living room maybe. All right, here we go. So the basics of fronts. The front is just a boundary separating two different air masses. They show up as lines on, and they have different symbols on weather maps, and the symbols always point in the direction that the front is advancing, unless of course it's a stationary front. And fronts are usually associated with lower pressure and converging winds. And so when you get those converging winds on a front, that's why you can get precipitation. So the first kind that we'll talk about are stationary fronts, and the name kind of speaks for itself. You got this kind of alternating warm front, cold front, warm front, cold front. So it kind of makes sense that this would be a stationary front. And usually the wind is flowing parallel, but in opposite direction of the front. So this would be, I guess, to the northeast, maybe, northish, and this would be to the south. Until you get the wind trying to come across the boundary, the front really isn't going to move a lot. There's nothing that really get these things going. So stationary fronts usually result in persistent cloudy, rainy, or snowy weather. Sometimes they can be a source for thunderstorms, but typically you just see kind of some rain or snow. In fact, that's kind of what we're seeing up in the Rocky Mountains. There's a stationary front up there gonna move across the country, transition into a full-blown system, but right now it's a stationary front, and seeing some snow with it in the Rocky Mountains. Next up is a warm front. So it's warm air advancing on cold air. So usually you have wind out of the south or southwest behind the front, and out ahead of the front you'll have winds out of the east or the northeast. So here's the warm front symbol, those red semicircles. And that front is moving in this direction. The cold air is receding. The warm front is kind of moving it on out of the way there. And oftentimes you get clouds forming along and ahead of that front because of that warm, moist air riding above that cold air. Remember, that warm air is going to be less dense than cold air, so it'll want to rise above it. And you can get fog, you can get rain, you can even get thunderstorms sometimes along some of these warm fronts, and especially behind the warm front. That's known as the warm sector when we're talking about severe weather, and that can lead to, especially in the afternoon, you get that daytime heating, those strong thunderstorms popping up. Linda, Hobbs, New Mexico. Not talking about Hobbs, New Mexico. seeing any of these fronts. Not a forecast, just talking about learning about fronts tonight. Next up, of course, we know these all too well in West Texas, cold fronts. You get that cold air advancing on warm air, and we track a lot of these in West Texas. Oop, what just popped up? I don't know, something just made a noise. So think of a cold front kind of like a boot. Here's the toe of your boot, and it's trying to kick that warm air out. That warm air is forced to go up because warm air, again, less dense than cold air. So that cold, dense air will want to stay down to the ground. The warm air will want to rise. And precipitation usually occurs ahead or along a cold front. Sometimes it can occur behind it, though. Remember back to our snowstorm back in February? That was a strong cold front that came through. And then we had all that precipitation develop behind it as another system kind of came in. So if you get that cold air in place and then the more humid air riding up over top of it, and it can produce precipitation, that's how you can get some good snowstorms. So those are cold fronts, and of course you see these a lot on our weather maps with the blue triangles. Occluded fronts, we're not going to see those very often in West Texas, but they are kind of cool to watch. Once you get these strong low pressure systems moving off to the East Coast or strong systems over the ocean, you can see this happen on satellite pictures. And remember that cold air is more dense. Talk about that a lot, say it a lot. Cold air is more dense, so not only is it going to want to sink and the warm air is going to want to rise above it, but more dense equals more mass over the same volume, I should say. So more dense equals more mass in the same area, and more mass equals more acceleration. So you're going to get this cold front going much faster than the warm front. And so when that happens, the cold front can actually catch up to the warm front, and they call that an occluded front. And again, rare in West Texas that you would ever see this on a Texas weather map. Usually the fronts here are just developing, so we don't get this kind of mature, strong low pressure system here. Usually they're in the development stage, which of course developing systems still strong enough to obviously produce interesting weather around here, but you're not going to get these occlusions here in West Texas. But just something kind of fun to look out for when you're looking at satellite pictures over the ocean, if you ever want to go and do that. Dry lines. We all know about the dry line. It's not really a front, it's kind of a front. Here you can see a weather map. I'm not sure which date this was taken actually, but you can see it's got these two stations highlighted here, and you can see that here's the temperature, here's the dew point. Dew point measures the amount of moisture in the atmosphere, and this one has a dew point, I believe that's San Angelo. That's a dew point of 67, and this is Fort Stockton. That's a dew point of 11, so that is a large difference. Much more humid air to the east of the dry line, a bunch of dry air to the west of the dry line. And of course, if you live here long enough, you know that these things can be known as the Marfa front. Separates that humid air from the dry air. Sometimes it can be represented with these dashed lines, but Anthony, Dylan, and I typically use those, that should say yellow semicircles, not white, should be yellow. And the semicircles point in the direction of the more humid air. And often it's a focal point for strong thunderstorms. And one fun fact is that dry lines tend to advance during the day and retreat at night, and it has to do with the temperature differences, because humid air warms up much more slowly than dry air. We see that when we get the very dry air here in the summer. That's when we can get into those triple digits, but if we get a little bit more humidity into the region, that's when we'll stick into those 90s and even some 80s sometimes because of the humidity. Humidity causes the air to not warm up as fast. And fronts, you can see those on satellite and radar. In fact, here's a good example from May 16th, 2017. What you actually have here is you have a dry line and you have a cold front. So I'll let it play again. Here's the dry line. The one that's moving from west to east is the cold front, and when they collide, that triggers a very strong line of thunderstorms there. I'll play the loop again. And at the beginning of it, you can already see on that dry line some storms there in the eastern Permian Basin starting to form. And then once the front and the dry line connect, that's when you see the explosive thunderstorms going off. And the reason you can see this is because those boundaries that you're seeing, it has converging air, and that converging air means that you get bugs and dust and all sorts of other stuff. All sorts of other stuff being detected by the radar there. And of course, once those go off, that's a big line of thunderstorms. And then this one, you can see this is what's called a rope cloud, and that's often associated with cold fronts. I believe this is out over the Pacific Ocean. And you can even see a couple of little thunderstorms there up in the top right corner. So the thunderstorms, the cold front acting as a focal point for some thunderstorms. Otherwise, you just kind of get this strong, this roll cloud. Kind of cool to see those. All right, now I have the demonstration for you guys. I'm going to pop up the camera over there. And so I've set up a little glass cooking kitchen oven, whatever you want to call it. And what we're going to do with this is I have some food coloring. It's like a pinkish kind of red. I think it's like officially magenta or something. And so this is that. And I also have a ice cube that I had sitting in the freezer for a while. And I colored that one blue. So that's going to represent our cold front, and this is going to represent our warm front, or the warm air. So I'm going to make sure that this is all looking good. All right. Just want to make sure y'all can see me. Oh, I guess I can do that from right here. All right. Perfect. Here. So here's the food coloring. Here's the blue ice cube. So what we're going to do, we're going to add a couple drops of this pinkish, reddish food coloring. That should do the trick. All right. So we got our red food coloring in there. Now I'm going to have to very carefully get this ice cube out of here, so I don't make a big blue mess all over our carpet. Anthony would be none too pleased. All right, and watch what happens when I put this blue ice cube into this water. Might take a second here, and let's give it a little nudge forward. There you go. Do you kind of see that? It's kind of hard to tell. There we go. Let's get some of this blue. It's hard to tell, but you could kind of see when that cooler water entered there, that red food coloring wanted to come back up to the top. I wasn't able to test this, so not the best demonstration I've ever done, but you get the idea. I need to get this blue food coloring off of my hands. All right, well, now you can kind of see it. You definitely get more of that sinking motion with the blue, though. All right, well, it's an imperfect science sometimes. Anyone got any questions that they have about fronts? Again, hopefully next week or the week after we'll do another Jeopardy, so might have to put a couple of front questions in there. As always, if you have any questions, comments, requests for things that you want us to cover in StormTracker 9 science class, go ahead, leave those in the comments, or send me a message on Facebook or Twitter. Be happy to get anything that you guys want first and foremost. Hopefully next time the ice cube does a little bit better job if we try and do that one again. Again, didn't have a chance to test it because I didn't really have anything to make a blue ice cube in except that. So if there aren't any questions, I just want to say thanks for tuning in, and be sure to tune in tonight with Anthony. He'll have your forecast. Denise, thank you for doing this. We really enjoyed this presentation. Hey, thank you, Denise. Really appreciate you tuning in. And I think Anthony will have something tomorrow. Don't know what yet. We kind of just come up with these on the fly. So hope you tune in for that tomorrow. Liz, good try. It kind of worked. It was hard to see on the camera. I was like trying to look through it, and you know how things go sometimes. Maybe the water wasn't warm enough. I don't know. Or my food coloring was kind of too dense. All right, you guys. Thank you guys for tuning in, and be sure to tune in tonight at 8:30. Trivia with Crystal, or I think it's a quiz show with Crystal, so that should be pretty fun. So be sure to tune in, and I'll see you guys next time.